All right, this is chapter 3.9 related rates. In related rates, this is actually our first application of differentiation in a calculus class. Usually, if not always, requires a geometric formula, and it also requires that we differentiate a formula with respect to an independent variable. In this case, it's going to be time. Okay, so let's take a look at in a couple examples of this, because that's really all we can do. Let's say that a pebble is thrown into a calm pond and the ripple that is sent out from the impact is moving away from the center at 3 feet per second. Okay, now this is simple. How fast, and that's the key word here, that means differentiate, rate of change. How fast is the area within that ripple growing in, let's say, t equals 6 seconds? Okay, so clearly, again, geometric formulas in almost all of these, if not all of these, would be the area formula. Area is equal to pi r squared, except we're going to take this formula and we're going to differentiate with respect to time. Because notice that t, which is time, is not in the area formula. So we're differentiating the area formula with respect to t. And there you can see we're differentiating a equals pi r squared. We're taking d dt of that formula. So simple, nothing complicated here. That gives us, by the way, dA dt, which, by the way, is what we're looking for. How fast the area is growing with respect to time is equal to 2 pi r dr dt. Now, there's only one other thing we have to figure out here, because we are given the value of dr dt. That's how fast the radius of this circle is growing. And we're told that it's growing at 3 feet per second. So the only thing we need to find out is what the value of r is. So in 6 seconds at 3 feet per second, r is equal to 18 feet. So very simply put, we're going to have 2 pi times the radius, which is 18 feet, times the rate, which is 3 feet per second. Multiply everything out, and we get, let's see, 54 times 2 is 108 pi square feet per second. Now, this is an exact answer. However, sometimes in WebAssign and sometimes in the textbook, they require an approximate answer, in which case you could just punch in pi and multiply it by 108 in order to get the approximate answer. I prefer exact answers myself. Okay, so this is one example. Let's take a look at the second example, and that will pretty much round it off, although there are many other type problems that are going to fit into this same category. And we're going to take a look at one other one. And a reminder that when you do these, you want to have a handle on a good set of your geometric formulas. You know, Pythagorean theorem, formula of area of a rectangle, the formula for the circumference of a circle, stuff like that you should know. So let's take a look at this next one. In this next one, let me see here. Hang on. Let me put this on pause for a second. Okay, so in this second example, we have two ships that pass each other. One ship is headed north, the other ship is headed east. The one that's headed north is traveling at 6 knots per hour. The one that's headed due east is traveling at 8 knots per hour. The question is, how fast is the distance between them growing in t equals 4 hours? Now, usually in all of these type problems, you not only need a geometric formula and some obviously specific information about what's going on, but you also need a when. And notice in this example that the when is t equals 4 hours. And of course, the key of how fast tells us that we need to use a derivative here, again, with respect to time. Now we have a right triangle, and the distance between the ships, okay, is the hypotenuse. So what does that tell us? Well, that means we need to use Pythagoras. So we'll use Pythagoras. Now, what I'm going to do here, just to make life simple, is that I'm going to call the vertical direction the y direction, and I'm going to call the horizontal direction the x direction. So I end up with a formula, x squared plus y squared is equal to d squared, the distance between them, which is the hypotenuse. And then I'm going to differentiate that formula like I did the other one with respect to time. In other words, I'm going to take d dt of that x squared plus y squared equals d squared. All right, so there we have it. I haven't differentiated it yet, but I'm going to. So I have an x, a y, and a d here. And I have to differentiate all of those three variables with respect to time. So what does that give me? Well, it gives me 2x dx dt plus 2y dy dt is equal to 2d dd dt. Now, one of the things that we also have to do once we've gotten to this point is that notice in order to come up with an answer here, since we're looking for how fast the distance is growing between the two ships, we need to solve this for d, but we also need to make sure that we know what the value of x is, what the value of y is, and what the value of d is. So the first thing I'm going to do is solve for d dt, because that's what we're looking for. So I have d dt is equal to x dx dt plus y dy dt divided by d. Now I'm going to have to do a little bit of algebra and geometry here. So if the value of y, the ship headed north, traveling at 6 knots, 4 hours later, so the value of y is equal to 24 knots, nautical miles, that is. And the value of x traveling at 8 times 4 is equal to 32 knots, or nautical miles. Now, the value of d isn't going to be that easy because you're going to have to use the Pythagorean theorem. D is equal to the square root of x squared plus y squared. Okay, so we have d is equal to the square root of 32 squared plus 24 squared. Of course, you can use your calculator to come up with this. Doesn't mean that it's always going to be a nice value here, but in this case, it does turn out to be that d is equal to 40. All right, let me show you what I have here. And the last step will be to plug everything in and actually calculate what d dt is. Okay, so there's my work. Okay, now we're going to plug everything in. We're going to plug in the value of x, dx dt, y, dy dt, and d. Use the calculator and come up with an answer. Again, it doesn't mean that the answers always have to be nice answers. Don't get lulled into thinking that is true. All right, so I have d dt, which is how fast the distance between the ships is growing. And I have x is equal to 32 times dx dt, which is 8, plus the value of y, which is 24, times dy dt, which is 6. And that's all divided by d, which we just calculated to be 40. So I'm going to use my calculator to plug all of this in and hopefully come up with some sort of answer, and it doesn't have to be a nice answer. Of course, once again, I'm reminding everybody that they need to know how to use this device. So I have 32 times 8 plus 24 times 6, and all that is divided by 40. And the answer comes out to be 10. 10 what? Not 10 bananas, but 10 knots, or 10 knots per hour. 10 knots per hour. Okay. Let me show you my work here. A little bit of a hint, people. Many of you are skimping in showing work on labs and exams. I've been a little bit easy on you on the first set, but I'm not going to go this easy on the next set. So when I say show all work, I mean show all work. That doesn't mean that I need to see you doing multiplication and division by hand. That I don't need to see. But as far as what's going on, like this is a good example. And there's plenty of other videos posted on the chapter review documents that you should be watching. These are mandatory. These recordings that I'm making for you right now, these are not optional. This is part of your course, just so you know. All right, I'm ending this.